How would you feel if you could solve a problem on the most prestigious physics exam in the entire world? And not one of those insanely old, like the first problem ever created on this exam. Something that's actually kind of recent. Well, I'm guessing you would feel really good. And today, that's what we're going to do. We are going to be solving a problem from the International Physics Olympiad. And without further ado, let's move on to the video. This problem is from the 2022 International Physics Olympiad. And this problem says a spaghetto, basically a single piece of spaghetti, or essentially just like a small tube or a straw, is a spaghetto which sags under its own weight until, let me respell that, until it snaps at a critical midpoint, or until it snaps in the middle at a critical length. If the diameter of the straw is 1 millimeter, the straw breaks at a length of 50 centimeters. At what length would it break if the diameter was 10 centimeters? So, this is basically the same problem. And I did paraphrase it as I don't want to completely copy off them. So, yeah, let's get into solving this problem. So, now we know that there are two main factors that would influence anything breaking when it's hanging on its midpoint. So, if we have the straw over here, and it's hanging precisely at its midpoint, sort of like a lever, basically there are two things. Number one, the weight, or mg, of the object, which is basically just the force that's pulling down on the object in order for it to be able to break, or since it's sagging, just the gravitational force. The other force is the resistance force, or just sort of a resistance that any object has of having its shape change, or its rigidity. I don't know if it's that word. It's a word now. So, now that we have these two forces, we're not giving anything else. And don't worry, we won't be using any other formulas besides what we already know. But all we do know is that for it to just start breaking, the forces will have to be pretty much exactly equal. Now, the biggest thing is when you have this weight pulling down, there is also a certain amount of object, just how long the object is what you're pulling down on. Now, this weight times the length is called a bending, or is basically just what we'll use for it to bend. Now, this weight, now don't confuse this with mass, this is bending moment. This is basically, well, we know what weight is. It's mass times velocity. But also, mass is also related to density and how dense an object is. So, if you've learned in any other class in the past, and this is a very elementary physics topic and something people learn very early, but it's also used in more advanced stuff. But basically, there you have, it'll be the density of the object times gravitational acceleration times some other constants, but that doesn't matter. It can be any other constants, but it's proportional to the diameter squared, or the surface area of the thing, because that really constrains how much stuff there is. Now, times, of course, the length. Now, what about the resistance force? Well, the resistance force, let's call it R, this would be pretty much directly proportional to, number one, we'll have some constant, but this, so we can set it equal to some constant, let's do rho, and this constant will be multiplied by the diameter cubed, as that shows how much stuff there is at the center to actually resist this. So setting these two equal, we get these two constants times d squared times L is equal to rho times d cubed. Then we get these two constants times L is equal to rho times d. Now, since we can just essentially discard all these constants and make it proportional, we get L is proportional to d. Sorry, no, L squared, because this would also be the volume and the amount of stuff, sorry. So it'll be L squared, so L squared is proportional to d. So L is proportional to the square root of d. Now, this basically means that an L1 divided by an L2 would be equal to the square root of d1 divided by d2. Now, we know what L1 is. That would be 50 centimeters. Or we can say L2 is 50 centimeters. So it'll be easier to solve. So L1 over 50 is equal to the diameter 1, which is 10 millimeters, not 10 centimeters, sorry. This would be 10, and this would be 10, and then divided by, after that we would divide this equation by diameter 2, which is 1, and take the square root of that. So we would get L1 is equal to 50 times the square root of 10. Now, in some ways, this would actually be very interesting, as, let's think about it. If, by any chance, if we would think, oh, if it's 10 times wider, then it would be 10 times stronger. And as a result, it would bend 10 times away. But no, since when you make it wider, you add that extra weight. So it in fact slightly counteracts this, so precisely so that it becomes the square root of the number instead, which is very unique and part of the beauty of problems on the International Physics Olympiad. The solutions aren't completely obvious, but they're so elegant and so precise, it's like almost as if they're predetermined. So that's really, really cool and a very interesting problem, and something really inspiring for people to go on and learn physics. So, thank you so much. See you in the next one. And I hope you really enjoyed watching this video, learned something new for it, or just found it entertaining. See you in the next one, and bye-bye.